Okay, so chapter 6 is going to mainly be about quadrilaterals. What are quadrilaterals? Four sides. Okay, shapes with four sides. This first section, though, is not going to be just about quadrilaterals. It's going to be about all polygons. What are polygons? Okay, shapes that are closed. They have multiple sides. Um, things like quadrilaterals. What are some other types of polygons? Circle's not a polygon. Why is a circle not a polygon? Okay, it has curved sides. Remember that polygons cannot have curved sides. They have to have straight lines, straight sides. So things like quadrilaterals, what else? Pentagons. What else? Hexagon. Heptagon. All right, so Kirsten's looking at her notes here. She's going down the list. All right, so we're going to look at all of these different types of polygons in this first section. We're going to talk about what makes them regular. Oops. What makes them, I thought I fixed that. Let me see if I didn't. I don't know why. Okay. We're going to talk about what makes them convex, what makes them concave, and then we're going to talk about these words. What's a side, what's a vertex, and what's a diagonal. All right, so starting with our first vocabulary here. A side of a polygon is just simply a segment that forms the polygon. So what would be one side in this picture? AE. Remember that when you name a side, sorry guys, I'm going to have to shut this down and start it over so it doesn't keep doing that. I don't know why it's doing it, but it is. Oops. Let's see if this is better. Nope, it's still doing it there. Let's try this. I do not know why it's doing that. It is. It is. It's my Monday. Nope. I have no idea. Doing the same thing as always. There we go. Okay, maybe it's going to work now. All right, so just remember that when you're naming a side, it's a line segment. Don't forget all that chapter 1 work that we did. Don't forget all that chapter 1 work that we did where you have to name sides by putting a line segment above them. Okay, so AE would be a side. AB would be a side. BC would be a side. Is BD a side? No, BD is a diagonal. A diagonal is simply a segment that connects any two non-consecutive vertices. What's non-consecutive? Okay, not consecutive. So what does consecutive mean? Okay, they aren't necessarily touching, but the sides would be touching. But when they're talking about consecutive vertices, vertices are going to be just simply the points A, B, C, D. So what would be consecutive vertices? Okay, so basically one right after the other that are making them. So give me two that would be not consecutive. A and D would not be consecutive. A and C would not be consecutive. What about A and B? Those are consecutive, okay? So a diagonal has to connect non-consecutive vertices. AC, AD, so forth. There are a lot of diagonals inside your polygon. Any two non-consecutive vertices creates a diagonal. Is everybody okay with diagonal? Okay, so diagonals, vertices, and sides. It's a star. Okay, if you look in your notes, you're going to see two charts. One is big like this, and the other one is really tiny. Do you guys see the two different charts? This chart, you have to know. You have to memorize. The second chart, you do not have to memorize. It is only, might help if you can spell memorize. Memorize. All right. You only have to know this chart. The other chart, every year I have students who ask me, well, what's this called? What's that called? You can Google if you have a question, or you can look at the chart if it's one of the ones listed. But you have to know 3 through 12, skipping 11. You don't have to know the name for 11, but I put 11 on the other chart in case you're curious. You should know that 3 sides is a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, 6 is a hexagon, 7 is a heptagon. I don't normally count off for spelling in here, but I'll be a little bit picky when it comes to these two, because obviously if you don't spell them somewhat correctly, you could be talking about the other one. So be really careful with hexagon and heptagon. 8's octagon, 9's nonagon, 10 is a decagon, and 12 is a dodecagon. What's an 11-sided figure called? Hendecagon. Okay, hendecagon. You don't have to memorize that one. You probably have never heard that before unless you had a teacher in your lower grade that talked about it. How many of you would say you've heard most of these words before? Okay, so you should know those words. We'll just say anything besides these is an n-gon, and we'll plug in the number. So if it has 11 sides, we'll just call it an 11-gon, or 13 sides, we'll call it a 13-gon, so forth. Okay? You will be asked to name shapes, so make sure that you know those names. Okay? Again, these are the names of some common ones that maybe you might have wanted to know about. Some crazy. The last one, hectatomyragon? I don't know. Hecatomyragon? Something like that. But there are infinitely many names, so you can Google them online if you're curious. Yeah, tetradecagon or tetrachidecagon. So some of them have a couple different options. All right. Ruben already did this for us. He reminded us that a polygon has to be closed and that it has to be made up of segments, no curves, okay? Also remember that they have to intersect at the end point. So in other words, this is not a polygon. For one, it's not closed. For two, it's not intersecting at the end points. The end point would be over here. Okay? So be real careful about that. The next several slides are going to be pretty simple, just getting the vocab down. So I'm going to call on you. Be ready. Get you guys back in the game. You're going to tell me whether it's a polygon, yes or no, and then you're going to name it by the number of sides. So is it a triangle, octagon, decagon, what is it? Okay? So let's start with Corbin. Polygon, yes or no? Yes, this is a polygon. And Peyton, what's its name? Hexagon. It's got 6 sides. Oops. It's messing up. So yes, it is a polygon, and it is a hexagon. Next one. Gavin, polygon, yes or no? Yes. Your polygons can go inside of them. So notice how these are kind of going inside. It is still a polygon. It's closed. It intersects at the endpoints, and it's not got any curves. Name of this polygon, Tate? It has 7 sides. Very good. So it is a heptagon. So you're just counting 1, 2, 3, 4, 5, 6, 7. Heptagon. All right, next one. Thad, polygon, yes or no? No. It has curved sides, so therefore you're not going to name it because it's not a polygon. So the answer is just no. All right, emerald, polygon, yes or no? No, it's open. It's not a polygon. All right, next thing they're going to ask you, besides is it a polygon and what is its name, is it regular or not? Regular is going to be really important. For a polygon to be regular, it has to be both equilateral and equiangular. What's equilateral mean again? Equal sides. What's equiangular mean again? Equal angles. Can you name a polygon that is equilateral and equiangular? A square. Okay, so a square, oops, I don't know why it keeps doing that. A square has 4 right angles. I guess so. And four congruent sides. It's not going to let me do it. Trying to go fast. There you go. All right, 4 right angles, 4 congruent sides, that's a square. Can you name a quadrilateral that is not regular, but is equiangular? A rectangle. Would you guys agree that a rectangle has 4 right angles, but it does not have 4 congruent sides? Okay, I'm not going to draw all the 4 right angles because it keeps messing up. But are you with me? It has 4 right angles, but it does not have 4 congruent sides. So it is equiangular, but it is not regular. What's the name of a quadrilateral that has 4 congruent sides, but does not have 4 right angles? Say it again. A rhombus. So a rhombus is equilateral, but not equiangular. Okay, so you can have 3 different quadrilaterals. One of them is regular, the square. One of them is equiangular, the rectangle. And one of them is equilateral, the rhombus. And we're going to talk about those special quadrilaterals throughout the rest of this chapter. Can you name a different polygon that we talked about last semester that is both equilateral and equiangular, but not a square? Triangle. And if you remember, we talked about the triangle and we said the triangle, if it is equilateral, it is always what? Equiangular. And if it's equiangular, it's always equilateral. But that's not true for the quadrilateral. You can have a quadrilateral that's just equiangular or just equilateral. Okay? But for the triangle, it's always going to be both. If it's not regular, we're going to call it irregular with 2 R's. Okay? Irregular. So, no, I won't. But like I said, just be careful with hexagon and heptagon. That's going to be kind of tricky. I never count often here for spelling, but I might correct your spelling from time to time. Okay, so we're going to decide, is it regular, is it not? What makes it regular again? Equilateral and equiangular. Okay. The second thing we're going to be deciding is it concave or convex? Okay, concave. When I think of concave, I think of something caving in on itself. So a picture of something that's concave might look like this. It's caving in. The definition they're going to give you is not that basic. They're going to say any part of the diagonal, if it contains points in the exterior, then it's concave. That's kind of wordy. So here's what they mean. If I draw a diagonal, oops, that's not what I meant to do. If I draw a diagonal, remember diagonal connects non-consecutive vertices. So let's say I'm connecting this point, I've got to fix that, to this point. These are not consecutive, would you agree? Because really I'm going from here to here to create my picture, right? So if I draw this diagonal, is that diagonal inside my shape? No, it's outside my shape, right? So if your diagonal is outside the shape, then it's concave. If your diagonal is always inside the shape, then it's convex. So notice these diagonals are inside the shape. This one has a diagonal outside the shape. Okay, caves in on itself. This one's caving in, this one is not. Any questions about concave versus convex? All right, we're going to check. You'll notice there's several examples next in your notes. I'm going to go around again and call on you. You're going to tell me, is it regular or not? And is it concave or convex? So regular or irregular, concave or convex. Remember, regular has to be both equilateral and equiangular. Concave is going to cave in on itself, convex is not. All right, Landon, regular or irregular? Irregular. It is equilateral, but it's not equiangular. Okay, so irregular. Haley, concave or convex? Convex. Good. So this one is irregular and convex. It is not equiangular. It does not cave in on itself. All right, next one. Let's go with Vasai. Regular or irregular? Irregular. It is equiangular, but it's not what? It's not equilateral. The sides are not all the same. So it's irregular. Caleb, concave or convex? Yes, which one is it? You got this. Is it caving in? Or is it not? It's actually concave. Okay, so let's check. Here's how you know again. Pick a point and then go to a point that is not next to it. So not this very next point, but maybe this point. If you draw this diagonal, is that diagonal inside the shape? Is this piece inside the shape? No. So that means it's concave. It is caving in on this side. If I draw this diagonal, it is inside. But all diagonals have to be inside for it to be convex. If any diagonal is outside the shape, then it's concave. Okay? So irregular, concave. Does that make sense, Caleb? Okay. All right, Michael, regular or irregular? Regular. It is equilateral. It is equiangular. Angelina, concave or convex? Convex. Very good. It is not caving in on itself anywhere. So this would be regular, convex. What kind of shape is this? It's a square because it has 4 right angles, 4 equal sides. So it is a square. All right. Next one, Matt, regular or irregular? Regular. It's equilateral, it's equiangular. Trey, concave or convex? Convex. It is not caving in on itself anywhere. All diagonals would be inside. So regular, convex. All right, are we getting the idea? Do we need to keep going? Okay. Go ahead for me here, Corbin. Regular or irregular? Irregular. Notice it is not equilateral. And if we kept going with these angles, this angle is definitely not the same as these two. So it is irregular. Hannah, concave or convex? Concave. It is caving in on itself, or again, if you connect these 2 points, the diagonal is outside the shape. So that makes it concave. All right. The next thing we're going to talk about are 4 kind of formulas that you're going to have to learn. Okay, and so we're going to be talking about the difference between interior angles and exterior angles, and the sum of the interior and the sum of the exterior. So first of all, let's just review. If I have a triangle, which numbered angle is an interior angle? Number 1. So number 2 is an exterior angle. All right. So we're going to talk about 4 formulas. We're going to be talking about interior versus exterior. And then we're going to be talking about 2 formulas that pertain to interior angles and 2 formulas that pertain to exterior angles. And although this is in your notes, it might be nice if you just have like a little chart written somewhere where it's all in one spot, because it's kind of broken up throughout your notes. Okay? So we're going to start with the sum of all of the interior angles. And you already know the sum of all the interior angles of a triangle. What did we learn last semester that the sum of all the interior angles will be? 180. Always 180 degrees. Oh, it's not going to let me. Good grief. It keeps changing, that's why. Maybe I'm not saving it. Try this one more time, see if I can fix it. Okay. Let's see if it went back. Hope we saved it. Okay, let's see if it works. Okay, so everybody agree, 180 degrees if I had all the angles in a triangle. All right, so what they're going to do is they're going to help us investigate a formula if I want to find the sum of all the angles in a quadrilateral, or maybe a dodecagon, or maybe a 1,000-sided figure. What if I want to know all the angles added together in a 1,000-sided figure? So what we're going to do is we're going to take each shape, and we're going to start from one vertex, only one vertex, and we're going to draw in all the diagonals that can be drawn in from that one vertex. So if I go from here, would you agree that's the only diagonal that there is from that vertex? Everybody agree? Okay, how many triangles did it divide that quadrilateral into? 2 triangles. So we have 180 degrees in this triangle and 180 degrees in this triangle, right? So what would be the sum then of all the angles in this great big quadrilateral if we add the 2 sums together? 360. So in a quadrilateral, it makes 2 triangles, and the sum is 360. Does that make sense so far? You could have used a different starting vertex. So what we're going to do is we're going to draw all the possible diagonals from one vertex. That way we're dividing it into triangles from one starting location. Okay? All right, so come down to the pentagon, drawing all the diagonals from that one vertex. How many triangles did it make? 3 triangles. So if each triangle is 180, what will be the sum of all the angles in a pentagon? 540. All right, hexagon. Again, same idea. If I go from one vertex and draw in all the diagonals, how many triangles does it make? 4. And so what's the sum of all the angles going to end up being? 720. Because we're going to take this 180 and we're going to multiply it by what? 4. Okay. Oops, didn't write. So do you see a pattern based on each shape? The triangle had how many sides? How many sides does a triangle have? 3 sides, and it was 180. The quadrilateral had how many sides? 4 sides, and it was 360. The pentagon had how many sides? 5, and it was 540. Hexagon has how many sides? 6, and it was 720. Did I give you a little chart in your notes? Okay, so here's this little chart. Flip over to here. Let's see if we can understand where this formula is coming from. If I have 3 sides, it made 1 triangle, and the sum was 180. If it had 4 sides, it made 2 triangles, and the sum was 360, because we did 2 times 180. 5 sides made 3 triangles, 540. Do you notice what's happening from the number of sides to the number of triangles each time? Say it again. minus 2. It's 2 less every time. Would you agree? 6 to 4 is 2 less. So however many sides we have, we're going to take away 2, and then we're going to multiply it by 180. So the first formula that you're going to have to memorize and you're going to have to use to find the sum of all the interior angles is simply the number of sides minus 2 times 180. Number of sides minus 2 times 180. So here's one we didn't put down on the paper. Let's say I have a decagon. How many sides is a decagon? 10. So what am I going to do to figure out the sum of all the interior angles? 10 minus 2, and then what? Times 180. Okay, help me out. What's 10 minus 2? 8. What is 8 times 180? 1,440. Don't forget your degree symbol. We're finding the sum of the angle measures. So they're going to ask you to find the sum of however many sides they want, and all you're going to do is plug that into this formula. However many sides it is, take away 2 times 180. Any questions on how to find the sum? Okay, be careful, because where I see students make a mistake in this section is they think 180 every time they think sum. They think sum of all the angles adds to be 180. That's only for what shape? Triangle. Any other shape, you're going to have to figure out what the sum is. Okay, so just be really careful. All right, second formula, and here that is right here in your notes, by the way. Second formula is going to be finding each interior angle. And we'll come back to this in just a second. But let's look at an example here. Read the question. Biggest part's going to be, do you understand what it's asking you for? So what are some key words in this question? Sum. What's another key word? Interior. It's going to be convex. Heptagon. How many sides does a heptagon have? 7. So it's asking you to find the sum of the interior angles of a heptagon. So far, we've learned one formula. You'll have 4 by the end of this lesson. That means we're going to start with this n minus 2 times 180. Oh, this is driving me crazy. I don't know why it keeps doing that. Maybe I forgot to click. Okay. So I plug it in. What's 7 minus 2? 5. What's 5 times 180? 900. What are we going to put at the end of 900? Degrees. So the sum of all of the angles in a heptagon is going to be 900 every time, all the time if it's a heptagon. Okay? If it's a triangle, it's 180. Okay, read this question. What are the key words in this question? Okay, 16 gone. Interior. Need to find the measure. It's regular. That's key. What's regular mean again? Equiangular and equilateral. Okay? So we want to find the measure of the interior angle. What interior angle? Each. That's going to be our next keyword. So we're not looking for the sum, we're looking for each interior angle. You can only do that if it is regular. So add this to your formulas. If it's regular, that means all the angles are equal. You can find out what each one of them is by taking the sum. So for example, let's take our triangle. Not related to this. We'll come back to this. If I have a triangle, what's the sum of all the angles? 180. If it's equiangular and equilateral, then it's regular. What could we do to 180 to figure out what each one of them is? Just divide it by 3. And we need to divide it by 3 because that's how many angles it has or how many sides it has, right? So if I want to find the measure of each interior angle of a regular polygon, any regular polygon, I'm going to take the sum, n minus 2 times 180, and I'm going to divide it by what? By n, which is the number of sides or angles. So we're just going to divide it by n. This is your second formula that you need to memorize. Really, you don't have to memorize it. If you just think, whatever the sum is, I'm going to divide it by how many sides or angles it has. That's going to give me each one. Okay, so it's just the sum divided by how many angles you have. All right, so let's see if we can find our sum first. If we want to find the measure of each interior angle of a regular 16-gon, we're going to do n minus 2 times 180 to get our sum, and then we'll divide it by how many we have. So what's going in for n? 16. So plug it in, 16 minus 2 times 180, and then we want each one, so we're going to divide by 16. If we wanted the sum, we wouldn't divide by 16. Tell me what you get when you type that in. $157.5? Exactly. Okay. So 157.5 degrees. Don't forget your degree symbol. So we're saying that if we drew a 16-sided figure, each angle in that figure, if it was regular, would be 157.5 degrees. Is everybody okay with that? Okay, so when you read these questions, you're looking for those key words. Am I trying to find the sum, or am I trying to find each angle? Is it interior or is it exterior? That's going to make a difference. All right, so let's talk about exterior. I'm going to come back to this in just a second. Let's go to exterior first. Oops. So go to here. Ruben? No, good question. So if they just said you have a 16-gon and you don't know if it's regular or not, find out what each angle is. You couldn't do that because you don't know what each angle, I mean, you have no idea to know what they are. They could be anything. You could find the sum of all the angles, but if they're not the same, there's no way to know what each one is. Okay? All right. So now let's talk about exterior. If you look at this picture, do you guys agree that this is an exterior? This is an exterior and this is an exterior angle? All right. Notice what happens when you add all of those exterior angles together. What is the sum of all of them? 360. Okay. Look over here at this shape. What kind of shape is this? Heard somebody say it. It's a pentagon. So now look at every exterior angle. How many exterior angles should there be? 5 because it's a pentagon. Add all those together. When they added them all together, what did they add to be? 360. Let's think about one that's not drawn here. Let's think about the square. Okay? A square has 4 right angles. If I draw an exterior angle on one side, what is this exterior angle going to have to be? 90. Why? Good. So would you agree that I could find this angle right here if I wanted to? Because these two angles have to be supplementary. What are these two angles when they're side by side and they form a straight line? Linear pair. So that goes back to last semester. We could find this angle, we could find this angle, we could find this angle because all of these are linear pairs, right? Okay, so if this one's 90, let's go out here. What does this angle have to be? 90. Keep going. What does this exterior angle have to be? 90. And then one more, 90. What is 90 times 4? 360. What do you notice? The sum of the exterior angles is always going to be 360. It's not a formula. It's just basically a fact that you need to memorize. If you have the exterior angles and you want to find the sum of all of them, it's always going to be 360. Doesn't matter if it's got 3 sides or a million sides. The angles will always add to be 360. Think about why that is. When you add in more and more sides, what do you notice happens to the shape of your figure as you get more and more and more sides? What does it start to look like? A circle. And what is the measure of a circle? 360 degrees. So if you were to add all these little angles outside here, they're always going to sum to be 360. And even when you have a million of them put together, that just makes it look more like a circle. It's still going to be 360. Okay? All right, so now let's apply it to this idea we had over here. If I know that it's regular, if this angle is 60, what is this angle out here going to be? 120. If this is 60, what's this angle going to be? 120. If this is 60, what's this angle going to be? 120. What do you notice about all the exterior angles? They add to be 360, and if it's regular, they are also all equal. And so if we want to figure out what each angle is, we could take that 360 and we could divide it by what? 3, or n for any shape. What's 360 divided by 3? 120. So if you want to find each exterior angle, only if it's regular. This will not work if it's not, just like Ruben asked earlier. Could we find it if it wasn't regular? No, we couldn't. If you want to find each exterior angle and it's regular, you can simply just take the sum, 360, and divide it by what? 3 if it's a triangle, or n if it's whatever sides. Okay, so 4 formulas basically that you need to know, and they're very similar on the last 2. You just take the sum and divide it by however many sides you have. If it's interior, this is your sum. If it's exterior, it's always 360. Okay, let's try some problems. So look at the next one, and I'll go back to the one we skipped. Okay, so read this. Let's pick out the key words. What's important here? Each. Each is important. Exterior is important. What else? It's regular, and it's a 20-gon. So which one of these formulas do we need to use? Each, exterior, regular, 20-gon. Okay, we need to look at exterior, and we need to look at the one that gives us each, because it is regular. So we need to take 360 and divide it by n. What is n in this case? 20. 360 divided by 20 is what? 18. And what do we put? Degrees. So we're saying that if we drew a 20-sided figure, each little angle on the outside of that shape would be 20 degrees. Does that make sense? Okay. All right, let's go back to the one I skipped. I know I keep having you flip back and forth, but let's go back to this one. Keywords. What are my key words here? Each, interior, pentagon. Okay, now be careful. Each, interior, pentagon. What did it not tell us? It did not tell us that it was regular. We can't take the sum and divide it by how many sides there are unless all of the angles are the same. Would you agree? Okay, and we don't know that this is regular. In fact, if we look at the angles, are they the same? No, this is not regular. So we cannot simply take the sum of the pentagon and divide it by 5. So let's think about what we did back in before we went to break, first semester. If I had a triangle and this was 2x, and this was 3x, and this was 4x, what did I do to solve for x? I added them all together, 2x plus 3x plus 4x, and I set them equal to 180. Same idea here, except do they all add to be 180? No, it's a pentagon. What does a pentagon add to equal? How do we figure out? It's 540, but we find it by using this formula, right? So we're going to do the same thing we did last semester, but we're going to have to find what it sums to first because we haven't memorized what it is for a pentagon yet. Once you do, you won't have to find it every time. You know a triangle's 180. What did we say a quadrilateral is? 360. And you might have those memorized pretty quickly, but pentagon, hexagon, octagon, so forth, you're not going to necessarily know those every time. So the first thing you need to do is find the sum. N minus 2 times 180. How many sides does a pentagon have? 5. So we're going to plug in 5. 5 minus 2 times 180. That gives us 3 times 180, which Tate told us was 540. Okay, so if you don't have that memorized, you'll have to find it every time. Number of sides minus 2 times 180. Once you know what they're supposed to sum to, then you just go back and do it like we did last semester. Add all the angles together and set them equal to 540. Is this making sense? Okay, so we're going to add these together. 18C plus 32C plus 32C plus 35C plus 18C, and add them all together, what do we get? Should add to be 540 total. Oops, did I miss? I think I went out of order, but it doesn't matter. Okay, so now we need to add all our like terms. What is 18 plus 32 plus 32 plus 35 plus 18? 135C equals 540. So now we're just solving this algebraic equation. What do I do to solve for C? Divide by 135. What do we get for C? 4. Okay. Is that our answer? What does it ask for? The measure of each interior angle. So when I look at this picture, what am I going to have to do to figure out the measure of each interior angle? Plug it in for all of them. Well, kind of. Some of them are the same, right? So we don't have to plug it in for the ones that are the same. So let's start with angle A. Measure of angle A is supposed to be 35C, so that's going to be 35 times 4. What's 35 times 4? 140. Don't forget your degree symbol. Use good notation from chapter 1. Measure angle A equals 140. There's not another 35C, so that's all we can do. Measure angle B. Measure angle B is 18 times C, or 18 times 4. What do we get for it? 72 degrees. Which other angle is also going to be 72 degrees? Angle E. So we don't really have to show our work there. We can just put measure of angle E equals 72 degrees because it was also 18C. Okay, and then the last one that we need to find would be angle C, and D will be the same. So what's the measure of angle C going to be if it's 32 times 4? 128. Don't forget your degree symbol. And so the measure of angle D is also 128. Questions? Okay, the hardest part is going to be, are you finding interior or exterior? Asking yourself that. Sum of the exterior is always 360. If it's regular, you just divide it by how many there are to find out what one of them are. If it's interior, for a triangle it's 180, but that's it. So be careful that you don't constantly think, add them to be 180. You have to find the sum. If you're wanting to know what one of them is and it's regular, divide it by how many there are. If it's not regular, Add them all up, set them equal to what it's supposed to equal. All right, let me see what's left in 6-1 and see if there's anything else I wanted to go over. There's 2 more, but they're the exact same kind of examples, except, so I'm not going to do the last one, but let's look at this next to last one, and we'll stop there. What's different about this one? Okay, they want us to find B, so we don't have to plug it back in. That's going to be quicker. We just have to find B. But what kind of angles are they giving us in this picture? Exterior angles, not interior angles. So what do we know? That all of the exterior angles always add to B, 360. Doesn't matter if it's got 3 sides or 1,000,000 sides. They always add to be 360. Same process then. We're going to add all these together. But we're not going to set them equal to 540. We're going to set them equal to 360. Okay, so again, you're going to be really careful. What do I have in my picture, interior or exterior? And then decide what the sum should be. All right, so let's do this again real quick. 33B plus 16B plus 10B. I'm just adding all these angles out here together. But this time I'm going to set them equal to 360. Okay, tell me what you get in terms of B. How many B's do we have? 120? Somebody agree? 120B equals 360. So we divide by 120. What do we get for B? B is 3. This time we get to stop because it did not say find each angle. Questions in 6-1. Okay, there's a lot of information. If you don't go back and study this, you're going to get confused. So we talked about what is a polygon? What are the names of polygons? Are they regular or irregular? Concave or convex? Then we talked about 4 formulas. Are we talking about interior or exterior? If it's exterior, they're always 360. If it's interior, it depends. Don't think only triangles. Think every shape. If it's regular, you can just divide their sums by how many there are. Any questions on 6-1? Okay, we only have about 15 minutes. I want us just to look at 6-2. Obviously, we won't finish 6-2. That helps. That gives you less homework. So that's good. Okay. Let's see if I got this one working right or if it's going to mess up every time I touch it. So now 6-2 is where we shift our thought process to only quadrilaterals. How many sides does a quadrilateral have? How many sides does a quadrilateral have? 4. From here on, the rest of chapter 6 is only about 4-sided figures. Okay? This section is only about one of those 4-sided figures called a parallelogram. We're going to focus on only parallelograms right now. And here's my advice to you. I would get out a clean sheet of paper right now, and we're going to make a properties chart. You don't want to lose this piece of paper. We're going to use it every day for the rest of this chapter. So put it somewhere safe. By the end of this chapter, you're going to have a list of properties for every quadrilateral. And it's going to be a great thing to use to study with because basically this test is going to be, do you know these few little formulas? Can you use your vocabulary correctly? Can you tell me this is an octagon? And then it's going to be, do you know the properties of your shapes? And that's the big idea for the entire chapter. We'll be talking about trying to determine what kind of shape it is and proving that, but big idea is, do you know the properties? And so we're going to start with the parallelogram. This list will keep going all throughout this week and next week. So we're going to start with first our parallelogram. Oops, that's a bad one. And we're going to list all our properties of a parallelogram. Each shape, we're going to start with the definition. It's going to be important that you know the definition. So you probably want to identify on your property sheet that this is the definition, not just a property. Okay? But we are going to talk about it as a property. But specifically, this is the definition for a parallelogram. So a parallelogram is, first of all, a quadrilateral. But it has what? What makes it a parallelogram? What does it say? Two pairs of parallel sides. So the definition for a parallelogram is it has two pairs. Actually, I'm going to write it as opposite sides. Opposite sides are parallel. And this is, remember, our symbol for parallel. Opposite sides are parallel. That's the definition. If you have a parallelogram, the opposite sides are going to be parallel. And remember, little arrows are how we show that they're parallel. The parallelogram is going to have 5 properties. You're going to have to memorize those 5 properties, but we'll use them over and over and over again, so hopefully it'll start to be really easy. What is something else that you know about the parallelogram besides opposite sides are parallel? Does anybody know anything else about the parallelogram? What do you think would be true about the opposite sides besides them being parallel? They're going to be congruent. That's going to be another property. Let's add it. So another property is opposite sides are congruent. So not only are they going to be parallel to each other, but they're also going to be congruent to each other. So I'm putting little congruent marks there on opposite sides, a different number for each opposite side. Okay, think about this. In my parallelogram, if these two sides are parallel to each other, and then I draw in this side here, if these are parallel, what do I know about these two angles when I have two parallel lines cut by a transversal? They're supplementary. Who said that? Tate. Do you guys remember these are called same side interior angles? And we know that the same side interior angles are supplementary. Okay, I'm going to show you where this is in your notes since I'm going through all of this. By the way, to name a parallelogram, I forgot to say this. To name a parallelogram, they're going to use this little symbol. It means parallelogram. It doesn't mean quadrilateral or rectangle or square. It means parallelogram. So they'll name it, always name it consecutively clockwise. Don't ever name it A. Obviously, I didn't fix that. Don't ever name it A, B, D, C. Because that doesn't make a parallelogram, right? That makes a Z or an N. Could be B, C, D, A. Just pick a place to start and always go consecutively around your shape, okay? You can go counterclockwise and it is still correct. So you could say B, A, D, C, but just don't jump around, okay? All right, so the first property that we already listed on the board was that opposite sides are congruent. That's in your notes. And then if you look at this next chart, the next one that we are going to list is right here, and it's what I was trying to show you, and Tate reminded us. See if this works. Right here, that consecutive angles will be supplementary. A and B will be supplementary. C and D will be supplementary. B and C will be supplementary. A and D will be supplementary because both pairs of opposite sides are parallel. So these are going to be same side interior. These are going to be same side interior. But going this direction, these are same side interior, and so are these. Okay, so third property really. Add this to your notes. Consecutive angles are supplementary. Consecutive angles are supplementary. Give you an example here real quick as you're writing that down. If you look at this picture, how do you know it's a parallelogram, first of all? The arrows, and they're showing you that both pairs of opposite sides are parallel. What would be the measure of angle Y? 120, good beside, because we know these two angles should be supplementary. So Y is going to be 120. If Y is 120, think about these two angles. What is angle X going to have to be then? 60, because those two angles are supplementary. Every pair of consecutive angles is going to be supplementary. So if X is 60, what would this missing angle that I didn't label have to be? 120. What do you notice about the opposite angles in a parallelogram? They're the same. That is your fourth property. The opposite angles are going to be congruent in a parallelogram. So let's add that to our chart. Opposite angles are congruent. So we've got opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and the last one, and where we're going to stop today, is in a parallelogram, the diagonals are going to bisect each other. The diagonals are going to bisect each other. Think about what that means. What does bisect mean? Split into two congruent parts. So if you draw in the diagonals, they're going to split each other into two congruent parts. So AC is going to split BD into two congruent parts. And BD is going to split AC into two congruent parts. Do you see what they mean by diagonals bisect each other? Okay, so fifth property, 1, 2, 3, 4. Fifth one and last one that we're going to list are the diagonals bisect each other. And if you need to, you might want to draw yourself a little picture beside it just to understand what that means. You're drawing in the diagonals, and they are splitting each other into two congruent parts. They are not all four parts congruent, but there are two pieces congruent and two pieces congruent. Okay, so homework, I'm going to give you a homework assignment. You're only going to work on the first page, but try to start memorizing these 5 properties because it's going to make the lesson on Thursday so much easier if you have this memorized. Ruben? Good question. Yeah. We are not, in this chapter, we may talk about some proofs, but on the review and on the test, we are not going to be writing 2-column proofs. I am going to ask you, the most I'm going to ask you to do is be able to tell me if you think a shape is a parallelogram, be able to prove to me why it's a parallelogram by basically just listing one of the properties. So when I say prove it, I'm really just going to mean list a property. Okay, that's as far as proving that we're going to go. So good question. No full proofs on this chapter. Okay, so just want to make sure you understand what you need to be doing before next class period, okay? First of all, since we didn't cover everything, this is not technically due. So when is this going to be due? Monday. But should you wait to do this? No, because you're going to have a lot more coming to you on Thursday. Okay, what part of this could you go ahead and do? All of the first page. Okay? So do all of the first page before Thursday. Do it tonight. Call me if you need help. Request encore for tomorrow. Okay, get it done so it's not something that's hanging over your head. All right. We are going to CAP next when the bell rings. So back to CAP.